All right, guys. This is the lesson 8.2 Z-test for a mean. This is very important, very, very important, especially if you're doing a project where you're comparing means to a number that you've seen in your research and your data. You need to use Z-test for a mean. We're also going to do Z-test for two means, and we're going to do a t-test and all that fun stuff. It's going to seem confusing at first. You'll do enough examples and you can ask me questions, you'll understand it. I've already pre-written some of the notes. I'm just going to explain them real quick. If you want to pause them after I give you a definition, pause to write down and then listen as I explain. So first thing is, what is a Z-test? It is a statistical test that we use for the mean of a population, used when n is greater than or equal to 30, we know that, or when the population is normally distributed and obviously your standard deviation is known. Okay, so we're going to be focusing on tests, something like, let's say we want to determine if the mean height of 8th graders is 66 inches. Okay, so I would then go and sample 30 random 8th graders, and I would measure their height, and then I would find their mean. Okay, does that make sense? I would find their mean, and I would compare it to see if it's greater than 66 inches. So I would make a claim that, I don't know, I think it actually is less than 66 inches. And then I would take my average and compare. So that would be a Z-test example. All right. Now, this test statistic we use should look familiar to you. Looks like this. Z equals x bar minus mu divided by sigma over square root n. So let's see. This is x bar, which you know to be your sample mean. So again, using my example of 8th graders, that would be the 30 8th graders that I took their sample mean. The mu would be the population mean of 8th graders, which let's say it's 66 inches. Standard deviation for the population, that is something that needs to be known to do the Z-test. And then obviously n being the sample size. How many kids did you sample? Okay. And this is what we call a test statistic. And we're going to look at this, our test statistic, and we're going to compare it to the actual Z-score that we should be getting. All right. Now, last and final thing to take in your notes, the 5 steps to hypothesis testing. You need to state your HO and HA and identify which one is your claim. This obviously should usually be your claim, your HA. Okay. Then you're going to find your critical values. We've already learned how to do that in 8.1. Go on our calculator. If they say a significance level of 0.10, we go to inverse, norm, and again, depending on if it's a right side tail or a left side tail or two-sided tail, you'll find that critical value. We compute the test value and write down a p-value. So we're going to compute this test statistic, but we're also going to write down this p-value from our calculator. Very important, that p-value, because that p-value is actually going to help us make a decision to reject or fail to reject. And there's a little phrase that I'm going to write down, and I hate to write it down. We're a Christian school, but this is actually how most people remember it. If the p is low, reject the hoe. I'm sorry. Sounds inappropriate, but this is how we remember it. If the p is low, we're going to reject the hoe. HO, obviously, null hypothesis. Only to be said, this phrase should only be said when using a test for mean or tests, hypothesis testing. And after we're done, we're going to summarize the results. Okay, I'm glad you're enjoying this. I know you probably just spit your juice out or something. But let's actually do some examples so this will make sense. So hopefully you've downloaded this, Statistics Z-Test for Mean. 8.2. Okay. Sorry, it's a little small. I'm going to try to squeeze it in here. A researcher believes the mean age of medical doctors in a large hospital system is older than the average age of doctors in the U.S. Okay, so this is what they're claiming. This is their. I think they're actually older, which is 46. Assume the population standard deviation is 4.2 and a random sample of 30 doctors from the system is selected, and the mean age of the sample is 48.6. Test a claim at 0.5 significance. All right. Wow, lots of information here. So let's not freak out. We can do this. We've done this before. Step number 1, you are going to state your HO and HA. Your HO and your HA. Remember, HA is what are you claiming? Well, let's see. The researcher thinks that the average age of doctors is greater than 46. So right here for HA, you would put my age must be greater than 46. Well, then what would our HO be? Well, this is always an equal sign. We're going to leave it at equals 46. So that's step number 1. You state your HO and HA, and then you can even put claim right here next to your HA. Okay, step number 2, we find our critical value and state the significance. Okay, so the significance level is this little guy right here, alpha equals 0.05. The critical value is where you go into your calculator and you do inverse norm. Now, do we put in 0.05? Well, again, this depends on what kind of tail we're talking about. So let's just draw this out right here. If I want a mean that's greater than 46, that means I'm looking for the tail on the right. Greater, right. Less than, left. Not equal to would be both. So I want this area to be 0.05. Is that how I put it in my calculator then, 0.05? Obviously not. You always put the left side in, which would be 0.95. Enter, enter, enter. And I get 1.64. 1.64 equal 1.65. Okay, so that's our critical value. That's the Z. If I land in here, this is my critical area. That's where I want to reject. If I land out here, I'm not going to reject that. Okay, so step number 1, HOHA. This is how you're writing it. Step number 2, write the word significance level and put the alpha. Critical value from your calculator, 1.64. Step number 3, we have to calculate our test statistic. And the test statistic is based off of this formula right here, okay? Our test statistic. So that would be Z equals X bar minus mu over standard deviation divided by square root of n. Okay, so let's kind of read through the problem again and find our X bar. What is our mean for our 30 people? What was the average? Assume the population standard deviation is 4.2, so we know this guy is going to be 4.2. A random sample of 30, we know n is 30, square root 30. And what do we got? It's selected, and the mean age of that sample is 48.6, so this X bar is 48.6. What's the population's age? 46. So sorry for squeezing that in all right there, but you're going to put that in your calculator. 48.6 minus 46 divided by 4.2 divided by the square root of 30. Okay? So let's see what we get there. Z equals 0.6 minus 46 divided by 4.2 divided by the square root of 30. And I get 3.39. Whoa, that's crazy. What does that mean? Okay. Now, on your calculator, at this point, you are going to go to tests. Remember how we were going to Z interval, T interval? Well, we're not doing that anymore. We're doing a test, Z test. Z test. So go to number 1. You're going to have 2 choices, data and stats, okay? Obviously, we've got all this stats, so we don't need data. So we're going to input stats in. So mu sub 0 is what is our population's mu? What does our population mean? And we know that that's 46. What's the standard deviation? 4.2. What does our sample mean? 48.6. And how many N sample people do we have? 30. Now, then you got 3 choices here. Not equals, less than, greater than. You choose the one that you wrote for your HA. My HA was greater, that's the one I choose. Okay? Then go to calculate and look at that. Your Z, 3.39. That's actually what I got right here. Your P, that's the P value we're very interested in. I need you to write that down. 3.48 e to the negative 4. What does that mean? That means your P value is 3. It is we moved over 4 spots. 1, 2, 3, and then 3. Your P value is a negative 4. You have to move that over 4 spots, 1, 2, 3, 4, and you would have 3 zeros in front. Your P is 0.0003. Now here's what you're going to do. You're going to compare this number to the significance level. Is 0.0003 less than, greater than, or roughly equal to 0.05? Well, it is less than 0.05. Wouldn't you agree? Aren't those two? So what does that mean for step 4? This is your fun part. If the P is lower than the significance, reject the HO, reject the HO. So you would write for number 4, I reject my HO. What does that mean if you reject HO? You are rejecting then this thing that saying that average age doctors in the United States is 46. No, that's not true. You did a sample, and your sample was like way out there. The p-value is 0.0003. There's no way. So here's what you say for number 5. There is enough evidence to support my claim that the average age of doctors in this system is greater than 46. It's pretty much like you're restating it when we were doing the intervals. All right, so that was very slow, very long way of doing it. I'm going to do the second example in a minute, but this is all we do every single time. State your HO, HA. State your significance level. Find the critical value on the calculator. Find your Z and the p-value from your calculator. Reject or fail to reject. Then write this sentence, there is enough evidence. If you reject, then there is enough evidence. If you fail to reject, then there is not enough evidence. We'll see that in a minute. And that's really it. It's just the same thing over and over again. If you do these enough, you'll get used to it, okay? All right. Stay tuned for the next example in a moment.